everyone and welcome to new discussion of this Geographic Information Systems course. As we have been discussing so far, it is all for the development of GIS spatial database. And once the database is ready, then the real analysis starts. And that is basically heart of the GIS, the analysis part. As you know that in earlier time when the GIS started coming in our life and in day to day many operations, we used to spend a lot of time on development of GIS spatial database. Slowly that time is getting reduced. The reason is because a lot of now data is available which is compatible to GIS formats. Depending, it is sort of independent of software, and that means many vector files are available in safe format which is acceptable or compatible with almost every standard GIS softwares. So, the vector data can directly be used into GIS rather than we ourselves are converting format and georeferencing and then organizing in our own database. So, directly either we can get from some organizations or from portal and can start using it. If we talk about the raster data, it is almost the same, that a lot of raster data is now available in TIFF or GeoTIFF format, and that means they are already georeferenced and we don't have to do any further processing on it. Directly again we can use in GIS. As you know that lot of remote sensing data based on different satellites of different countries is now available on net free of cost, and that too very well organized in georeference, and sometimes well organized products are also available. And those products of like MODIS sensors products, there are various products which we can directly use in our GIS analysis. So, what I said in the beginning that the time which we used to spend to development of our GIS database is now getting reduced, and we can spend now more time on GIS analysis. That is the basically purpose of GIS, to do various kinds of analysis. So, in this we can see that again GIS analytical operations can be divided in two main categories. One is the primary category which involves the basic GIS functions. Sometimes we also call as GIS tools. For example, we do very basic measurements like area, perimeter, distance measurements, say between 2 points, area of a polygon and length or distance along a line, and likewise. So, these we put under category of primary operations. There are few more. Buffer generation, which we will be discussing as a separate discussion. So, buffer generation is also we can put in primary analytical tools or analytical operations. Buffers are very useful in many cases, and if we can make more realistic buffers involving some other parameters, like for example for smoke plume. So, simply we can draw a circle along a point source from where the smoke is coming. But if we can involve in the impedance for example the wind direction and which speed, maybe the terrain if there are undulations, and maybe the vegetation or height of trees or buildings, then we can really create a very genuine or very realistic buffer about the dispersion of smoke plume or pollutants. So, buffer generation though it comes under primary operations, but it is a very useful tool or useful operation of GIS. Similarly, we can do the reclassification because for example, we do lot of image classification on satellite images, and similarly we might be having a continuous data like raster, for example a digital elevation model which is a completely continuous information. Now, we want to classify into different categories, and therefore, from a continuous we can make it as discrete or in different classes only for our display purpose. So that the interpretation of such continuous data can become much easier. For example, we can reclassify a digital elevation model into a relief map by giving say 100-meter height elevation of a mean sea level to 200-meter one category, 201 to 300 another category, and so on and so forth. So likewise we can do the reclassification. So that is also put under this primary simple operations basically. So like for example, if I go for another operation like data selection, query, retrieval, these are also very simple analytical operations. In some of the demonstrations you have seen that how a GIS database can be queried, putting a very simple syntax or maybe a more nested syntax we can put and can retrieve the information from our database, GIS database. So that we put under this category of data selection, query, retrieval. Reclassification, as I just mentioned, that from continuous data to discrete data, sometimes it is required, so we perform that too also. Then we also do overlaying operations, which we will see in a complete separate discussions, which is based on set theory, Boolean logics, and this is how the complete mathematics have been sort of imported or implemented into GIS through overlaying operations. So that we will have also discussion. Then region transformation measurements, all these are also performed. And then neighborhood operations, there are many neighborhood operations because GIS is the only technology where the relationship between neighboring objects can be exploited. So that also. Then another analytical operation of GIS is the connectivity operations. So we will also have discussion on that later on. So first one is the attribute or a spatial query or retrieval. Basically the query generally done on the attributes, and suppose you are having point data and the point that corresponding attribute table might be having 100 fields. Now I can query a single field, put a condition, or I can query all the fields together and putting a nested query, and by which I can retrieve the desired data from my database. The only condition here is that whatever the output which it will generate, if I involve more than 5-6 attributes together through a nested query, then I have to interpret, I have to understand that data or that output. So one has to be very careful. The best solution is go in steps. So first you query using few attributes or few fields of your database, and then in the next step again few, and after each operation you can check for errors whether the results are coming all right, understandable, usable or not. So that way we can perform a very nested query in a step manner. So this as you know that it involves the processing of attribute data independent of spatial information, and then spatial query, that means performing query on the spatial objects, that is also possible, and this is basically done through the selecting the features based on their location or spatial relationship. So like we can draw a circle or we can use a polygon. That polygon may be representing a state boundary or a district boundary or a watershed boundary or basin boundary, something like that. And based on that we can do the selection, and once these selected features are there, either we can save as a completely separate file, or we can just utilize whatever the selection has been done. So basic spatial analysis basically involves both attribute and spatial queries. So this comes very this is very frequent operation which is done on GIS system or on GIS database, which involves basically the querying the system and retrieving the information as per user defined specification. If you recall the definition, that was the last part of the definition, is that we model as per user defined specification. So user has to define what is his requirements, what he is looking, or taking out the data or querying them from the system. Now, spatial querying is the process of selecting features based on location or spatial relationships, and for example, all features within 30 kilometer of a road or 300 meter of a road. That means creating a kind of buffer. Using buffer, a spatial query can also be performed, and functions that allow a user to find or display or isolate attribute records linked to map features. As you know that in our GIS database, both spatial and non-spatial, that is attribute data, they are having a link or a dynamic link between these two. So, if I do a search or a query over attributes, same times my spatial objects are also selected, and in same way vice versa is also true, that when I perform a query on my spatial objects, then the same time my attributes information are also selected. This I earlier demonstrated through a demonstration class also. Now, the first is about the data selection retrieval. So, data retrieval involves the selective search. We can make different kind of searches based on our requirements. Only thing we have to care about the syntax and brackets and other things. Sometimes we get lot of errors if we do not put the query or the syntax properly. So, one has to be really very careful while doing these things, and whenever the data is out or whenever a selection is done, one has to be careful to understand that one, whether right selection has been done or something wrong with my query. So, both spatial and attributes data we can involve, and one important point here is that when we do the spatial query or attribute query, no changes are made in our data or neither in our spatial data or vector data or raster data. It is just querying the system, selecting whatever is available in our GIS database, and also no new spatial elements are created. That means when I perform the query, there will be some selections. That does not mean that new objects are being created or new attributes are being generated, not at all. And so, this is not done. However, if I am measuring area or length or distance between 2 points, then definitely a new field may be generated in my this attribute database. So, one only when we want that a new field should be generated which will populate the area, length, perimeter or centroid, then only it will be generated. Otherwise, in a normal query, no spatial element or no attribute is generated by the system. And of course, to find what, because the purpose of GIS is to answer few questions. So, when we involve the location, then we can answer a question what is at that particular location. So, that question can be answered very easily. And also, all spatial objects, whether they are point, line, polygon or mapping units in a raster, that means cell or pixels, can be retrieved, can be selected, and accordingly then we can utilize them. So, this if we perform this kind of analysis or retrieval, then we can answer a question where is. So, that question can be answered very easily. Now, this retrieval, you might have seen the map calculator in, say, for example, in ArcGIS or in simple the query builder in different GIS softwares. So, what you would find that they allow us to use various operators, and what are those operators? Like conditional, if this is greater than this, then select. So, these are the conditional. Logical also, you can greater than, less than, or arithmetic operation, trigonometric operations, all kinds of mathematical operations which are possible, might be possible, are available through this map calculator or query builder. So, we can perform quite easily, and similarly these overlaying operations are also done through that also. So, this is how these map calculators work, that you are having lot of such operators available, and which you can use in a single step, or all operators may be in one query, but one has to understand the results also. Now here what I am taking an example of data retrieval, and that too from the raster model. So we are having grid on the left side, and now what basically the query is that what is at. So what is at that particular location, which is shown through this arrow, as you can see about this cell. So the location is shown here, the column number is shown here, and then value is shown here. Now there are three layers. One, the top layer is the soil layer, the next layer in the middle layer is the rock layer, and the last layer or bottom layer is the slope layer. So when I select this particular cell, then from the soil I am getting the information that the soil type is the soil is silt and the thickness is 5. That means I am having in attribute I am having some information. But this is though I have mentioned that it is raster, but basically as you know that raster can have only one attribute. So how two attributes are coming? These can come through our vector also. So we can have a vector based grid also. So in that way these two can come. Otherwise there can be only one attribute associated with each cell or pixel in the raster case. Same with the this rock layer, we are getting the rock information also, and similarly from the slope map we are getting the slope information. So likewise if I put just select one cell where what is at, and then I get the information, and that is very simple way of data retrieval. Now as you know that these search functions constitute one of the most commonly used neighborhood operations. This is what I also described earlier, that these are the very common, and you know almost every day if you are having a good GIS database available and you use regularly, then these are the search operations or search functions are used very commonly, and you try to also get information from a neighborhood also. So this determine basically through this you determine the each target feature according to some characteristics of its neighborhood, and also the search area depending on the area of interest or a region of interest. Usually that may be square in shape, may be rectangular, may be circular, or analysts determine the size. That means that I may have a boundary which is arbitrary boundary like a district boundary or a watershed boundary or basin boundary. So it is not necessary that I should have only the square, rectangular or circular. I can have any shape and still I can perform search either on the vector data or raster data without any problem. Now after this data selection, query and retrieval, now we come to the second most common analytical operations in GIS is reclassification. As discussed earlier, that the purpose of reclassification is to reduce number of classes from original map or from a continuous data to reduce to only few classes. So now we will also see some examples as well. So if we go for definition of this, that it basically reclassification involves selection and presentation of a selected layer data based on the classes or values of a specific attribute. Now if I give the example of digital elevation model, then the attribute, there is only single attribute and that is the elevation. So I can perform analysis on that one and can get a new map, and instead of that map we will not call as a digital elevation model, then we will call as a relief map, and it will have different categories. Similarly, I can do the reclassification of a soil map into the pH map if I am having a attribute for that, and classifying an elevation map into the classes with intervals of 50 meters. This example I have already discussed with you. So this classification basically or reclassification based on the number of classes before and after the classification. So, there are three different types of classification techniques. So, reclassification techniques are available. One is the first one is one-to-one relationships. So, that the number of classes before is the same as the number of classes after classification process, and there are no changes in the geometry of spatial objects, and they have been reassigned. Only the values are reassigned, and this we put as a one-to-one. Now, there can be two other types. Next one is many-to-one. That means now we are reducing number of classes. In the previous one, we are reassigning. So, there is no changes in the geometry, because when we do not combine two classes, therefore, the geometry will also not change. So, number of classes in one-to-one example will remain same, whereas one-to-many, that means I am many-to-one, sorry, then I am reducing number of classes, and that involves the aggregation, merging, generalization also. So, it will go for less number of classes from original one. And the third possibility is one-to-many. That means I am now expanding, and of course, the reassignment is being done, and I might be splitting my already existing objects or number of classes. So, I may be going for more number of classes. So, three types: one-to-one, many-to-one, and one-to-many. All these three things, sometimes for some special purposes, we have to do it on our data, so that we can then compare with other layers, other themes, or other data sets. Now, I am bringing one example. Of course, this is a vector data example, means it is a polygon map, and there are different classes, as you can see, or different rocks which are present in this map, which are given in abbreviated form here in the legend. And now, if my attribute table is having some other information related with these units, then I can reclassify this map. For example, I can reclassify this map into the geological map, reclassified into 7 classes based on their geological age of different units. So, here you are seeing about 20 classes, those have been reduced, that means many-to-one, and those have been reduced to only based on the age. So, in my attribute, I must be having information about each polygon or against each rock type, what is their age. So, if I am having that information, the same polygon map I can reclassify using age column or age field as here done. So, there are now 6 classes. So, instead of 20 classes, and therefore, the maps becomes difficult to interpret, now I have reduced to just 6 classes based on their age, earlier based on their rock types. Now, also I can do using same map, I can reclassify into just type of lithology. Type of lithology means whether they are sedimentary rocks, igneous rocks, or metamorphic rocks. And so, from 20 to 6 in this example, and in the C example we are having from 6 to 3. The only condition here is that our database, attribute database, must be rich, must be having those fields which I can use to reclassify my polygon map, and that way we can do it. So, a lot of information is required, and if that information is already in my attribute table, then all such operations are very easy to perform. Similarly, here also a little different example, that reclassifying a map based on attribute information. So, what is this attribute I am having against each polygon is the land use, how this land or different plots are being used here. So, these are the basically city blocks are there, and this is the land use. So, the same I have reclassified into this one, and this example is one-to-one reclassification. That means there is no merger of 2 polygons, and there is no new generation of or boundary of any polygon. Whereas in previous examples, from 20 to 6 when we came, we have a reduced number of polygons in my display, not in really in database, only in for display. And when we went from 6 to 3, further reclassified based on the type of lithology, that means sedimentary, igneous, metamorphic, then only 3 3 types of polygons are there. And so lot of polygons which were present here in the center part or the southeast part have been merged just as a red color, and that is igneous rocks. So all kinds of possibilities are there, and we can perform those analysis like that as per our requirement or as per user defined specifications. If we are having say reassignment based on the attribute value, again example is here that I am having one is 1 2 3 here as the soil map. Now I am having against each my cell I am having another information, that is infiltration. So infiltration values if are available, I can reclassify the same map. If 2 adjacent areas are having same infiltration value like here, and so for on a screen they are appearing as one single polygon, but in the system each cell or other things are stored completely differently. So likewise that if this condition applies, we can do that kind of reclassification. Similarly, a reclassification is done that generate a new map if soil maps equal to red GINA, otherwise and if it is true then 3, otherwise 0. So this is what is done. So this the green one is the red GINA which is satisfying this condition of my query, and rest are not. So this is conditional operation and rest are not, so the 0 value has been assigned for the rest area. So as I have mentioned, you can use all those operators which are available in your map calculator or query builder, but the output you have to understand. So instead of using a very complicated nested query, do it in several steps using simple query. Also one example, the data classified from tables from the attribute. So you can see here that infiltration values can be done like that. Now DEM classification I have already given example. So like here the values are varying, elevation values in my grid are varying between 0 to 90, and this is my digital elevation model. When I reclassify it or classify it, then I am creating category that 0 to 200 meter should get this color, and 200 to 400 meter should get this color, and 400 to 900 meter should get this color. So instead of now having a continuous digital elevation model or continuous values in my digital elevation model, now I am having just 3 classes, and I can give name that very high elevated areas or middle elevated areas and low elevated areas. So likewise usage or utilization of such reclassified maps can be very useful. From digital image processing parlance or point of view, this is also called slicing, density slicing. So same, because the concepts are coming from different domains, so the same word, same term can also be used here. GIS softwares are also capable of reclassifying based on some automatic classification methods. For example, like involving the statistics, equal interval or equal frequency classifications, that is also possible. So if this is my input map, I can classify this way or this way. That means I am having either equal interval or equal frequency classification. So see here, now the frequency is almost same 6, 5, 6, whereas here the frequency was not maintained, but the interval between classes have been maintained. So 1 to 2, 3 to 4, 5 to 6, something like that. So this brings to end of this discussion, and of course then we will take the next topic related with this GIS analysis operations. So thank you very much.